So let's learn the new concept, the array. Okay. So what is array? How we are going to define it? Array is a homogeneous collection of data, or it's a similar kind of data, are possessing the same property. The contents they have possessing, or it's also called as homogeneous property. Homogeneous data. Okay, homogeneous data. Okay, so arrays, how it is? They are indexed. They store in continuous memory allocation. How the memory allocation is? Continuous. Indexed they are, continuous memory allocation is there. You are going to have the memory allocation is continuous. It may be the static or dynamic. The memory allocation can be static or the dynamic. Then easy to access. Accessing is easy, for which searching is easy. Okay, so this is array. Array means how we are going to, what is it, is a similar kind of data, or we are going to call it as a homogeneous collection of data. They are indexed. Indexed means if I say int a of 5, it means that the first value it represented in this way, it is a single dimensional 0 1 2 3 4. So indexing of this is a of 0, a of 1, a of 2, a of 3 and with a of 4. This is what we called as a indexing the data. Accessing will be easy. If I want to access a of 2, then simply I can write printf %d a of 2. So accessing is also easy here. Accessing here, the array can be a static or a dynamic. By using a dynamic, there is a free and delete in C++, malloc, calloc and realloc in C. Okay, we have the different way we can do it in a allocation of dynamically. So let's see how to define and how, what is the representation. Once it comes to the types of array, types of array, types of array. Okay, they are classified based on the subscript. The arrays are classified based on subscript. Number of subscripts are associated with an array. So they are classified. How they are classified? If the classification comes, then it is a single dimensional array. Single dimensional array. So for example, int, it is an array of one subscript. Hence it's called as a single dimensional array. If it is with a two-dimensional array, that is int array of, here it's a 10, it's a row and column. Okay, two are there, row and column. For example, it's a matrix. Okay, for example, this is a contiguous allocation. Three-dimensional array. So it's int a of x, y and z. That represents is this x, y, z. This data represents the x, y, z. This example is matrix, rows and columns. This represents the memory representation. That's a single dimensional. This represents the row and this represents the column. Okay, here the three directions. And next comes as a n dimensional array, like a diamond where you have the n dimensions. So this is the types of array. The arrays are classified based on the number of subscripts are used along with an array. If it is array is with the one subscript, that is called single dimensional array. Array with the two subscript, that's called as a two-dimensional array. Example, matrix representation for a matrix applicability. Array with a three dimension, that is called as a three-dimensional array, and so on with the n-dimensional array. So here each arrays, the dimension or subscripts are represented with the pointer. Okay, what we called as a pointer. They itself here are going to represent with the counter. Counter, or we can say as a pointer to the address. Counter variable, that is I. Normally we are going to use I for a single. Here it is for a row and column for the R, I and J. Here I, J, I, Z, X goes on. So this is the way we are going to do. So let's go with the single dimensional array. How to do that? How to represent the single dimensional array? Okay. What is single dimensional array? Array with one subscript having the homogeneous data and stored contiguously. Okay. What is that? A single dimension, single dimensional data, dimensional and homogeneous property. Homogeneous property. All are with the same behavior. What is that same behavior? It may be the integer, it may be the float, it may be the double, it may be the char. So all the data of a same, that is called as a array. Here it is one dimensional. Why? Because of it is a single subscript. So syntax, how to do that? Data type, array name, subscript, and it represents the size and semicolon. So this is an syntax. If it go for the example of the primitive data types are the valid data type. Primitive data types comes as like they are directly operated by the machine instructions. So int a of 20 size, then float b of 2, okay, char name of 25, okay, so double, you can have double salary, okay, salary of 4 digit, 5 digit, how much you want to give. So this is the example. If it is comes as a memory representation, how this array is memory representation for a single dimensional array. Presentation, that is, if it is int a of 10, how it is to be? It is of a integer data type. It takes a 2 byte of memory. How much it is? If it is a 32-bit operating system, it is a 2 byte. If it is 64, then it is a 4 byte. So how much it is? 20. So the indexing will start from 0. This is the name of the thing. It will start from 0, 1, 2, 3, 4, 5, 6, so on up to n minus 1, where I starts from 0 to n minus 1. Hence, this is called as an indexed array. So, the first one is a of 0, next a of 1, 2, 3, 4, 5, 6, and so on to the n minus 1. This is how the memory representation and the definition of a single dimensional array. So, let's take an example. What are the ADTs we can perform on the array? What are the ADTs we can perform on the array? What is that ADT is? Abstract data type, or operations which we can perform on the array. Operations to be performed. Like the first operation, we need to create the array. Okay, then we are going to read the element into the array. We can traverse array. This is called a display, or we also called as traversing the elements from the array. Then whether the array is empty, array is full, okay, then search the element from the array, delete the element from the array, swap the array element, okay, sort the array element. So there are many operations we can perform on the array. So let's take with a simple operation. These are called ADTs, abstract data types. That is, it tells that what are the operations we can perform. So let's take a simple program to demonstrate with an array. Okay, so let's create hash include std standard input output dot h in main. What we are doing? We are taking the integer size is n, then the array we are giving with the size 50, and one of the counter which represent the index. Okay, a pointer to the index. Now first we have to printf by asking the user that enter the size, how much size you want, because the default size is 50. As soon as you are going to declare, so in a computer memory, the memory is allocated contiguously by having the memory addresses in a hexadecimal format like OX. This is assumed that at the 2002, then this is assumed that at 2004, this is 2006, okay, 2008, and so on somewhere. Okay, so it goes on. So this is in the hexadecimal format. So it given to 0 to 49. So what is the allocated? 1, 2, 3, 4 and so on. It is to 49. That is I starts from 0 to n minus 1. This is as soon as it is declared, this much memory is allocated into the computer. Memory is allocated. But I want to use how much the size. So I can take the size of the element, that is %d n. So I am reading the n now. So enter n is, I have taken n equal to 2. So how much memory at present I want to use? That present I want to use 0, 1, 2, 3, 4 and so on. So I want to use the memory n equal to 2 means at present I want to use this much memory. So n is given. So two elements I am going to enter. So printf, enter the elements one by one. Enter elements one by 1. I am going to read the element. If it is to enter more than one element to read, then we need to have the for loop. I equal to 0. Regarding for loop, I have explained. You can go with the previous class. So I plus plus. So let's read the element here. Scanf %d as it is an integer. The name of the array is address we have to give and I. Okay, so it has been read. This is called reading the element. If you want to display the elements, so printf, the elements read are printf, elements in the array are, elements are, again we have to use a for, counter starts with 0, it will go up to n, as it is from the 0, hence it is n, otherwise if it starts with 1 means we have to write less than or equal to. Okay, so printf, the array elements are going to display here, that is ARR of I. Okay, so array elements of I. Then as it is an integer, so you have to say return 0. Okay. This is a program, sample program to read the element. Here reading the element, we are traversing the element, we have created the array. Okay, initialization and all things comes. Here n equal to 2, then the first element I am reading and it's storing into the element of I. Then I am going to read one more element, that is 500. It read and first it stores into A of 0, then it stores in A of 1. Later while you are displaying the element outside, that is the array of 0 is 1 and array of 1 is 1. Even you can make here formatting so that you can understand how you want to display, that is A of 0 is equal to the value is 20, then A of 1 is to be 500. You can display in this format also. So this is all about an array. Thank you.